So you're just adding these to the notes that you already had. So differential equations, just to make sure that we all understand, we're just going to kind of summarize what our video notes were, just to make sure that we're okay. Have you guys ever heard college people complaining about DiffyQ, their DiffyQ class?
No.
Oh.
No, I haven't heard. The only time I've remember hearing about differential equations is in this Harry Potter fanfic that actually uses it. It's literally the land of differential.
And another wolf has died.
That makes sense. Okay.
So anyway, as I was saying, yeah. So somebody shoot it. Oh man. So that's funny. So we only do a unit of this, so we're kind of getting like an intro to it, but differential equations, there's actually like full college level math classes that are just on differential equations. So there's a lot of crazy stuff you can do with them. So I never took a differential equations class. Yeah. So, and I'm a math teacher now. Well, it just means, because it's like, it's one of the classes that's above calculus, right? So when you go, for me, when I became like a math teacher, was taking the classes for that, you have to get to calculus, and then after that it like branches out, and there's not necessarily a list of classes you have to take, you just have to take this many credits. So you could like avoid it if you wanted to. Does that make sense? Because there's like tons of math classes, you just have to take this many, and once you have this many credits, they go like, you know enough, you can teach up to calculus. If that makes sense. Mm-hmm. I took calculus in high school, and I was like, that is my goal. So I knew when I was sitting in your seats, I was like, I'm going to teach calculus someday because I loved it. I loved it that much. Yes. I did have a good teacher. Her name was Merle Eddy. She was near retirement age. She laughed. She yucked when she laughed. Yuck, 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 yuck. That's how she laughed. She was wonderful. Yeah, exactly. Yeah, like Goofy. He yucks. Yeah, she laughed like that for real. She was very charming. All right, differential equations. So each equation, you're going to have y primes. Y prime apostrophe s? That's weird. That's not a quotation. That's a y prime apostrophe. Y prime plural.
Can we do a God name and a y prime apostrophe? Yeah, that's so weird.
So y prime is in the equation with the x's and y's. So differential equations are not just in terms of x and y, they're in terms of x and y and derivatives. You can still have c values. So you can have your constant, your plus c in there. And the solution of a differential equation is a function, not a point. And it's okay if some of that still feels a little abstract in your brain because we just started the unit, and as we go a little bit further, stuff will start to make some more sense. Okay? All right, so here's example number 5. We are going to verify that y equals c sub 1 cos x plus c sub 2 sin x is a solution to y double prime plus y equals 0.
Going to be a negative value of itself.
So we have y equals c sub 1 cos x plus c sub 2 sine x. And then what do we have to do? Yeah, we're going to single prime it first, though, right? We're going to find the first derivative, and then we're going to find the second derivative. Okay. That's how you double prime. So what's the derivative of cos? Negative sign. What does it mean when it says c sub 1 in the front? Constant, but it's a coefficient because it's in front. Two different constants, two different numbers that are in the front. Okay. So c sub 1 cos x, the derivative of cos is, so that's negative c sub 1 sine x. Okay. Derivative of sine is cos. So plus c sub 2 cos x. Okay. Then we have the derivative of negative sine. That's negative cos, so negative c sub 1 cos x. The derivative of cos minus c sub 2 sine x. Okay, and then to prove that that's a solution, we have to add the second derivative and the function and show that they equal 0. So second derivative plus the function is 0. And we can see that those are opposite signs, so those cancel out. These are opposite signs, so these cancel out. 0 equals 0. And we're done. Math. Therefore, math.
A horse walks into a bar, the bartender asks him if he wants a drink. He says, I think not. He disappears. Now, most people who rent a car would get a joke, and he says, I think before I in this case, you can never put the car before the horse.
All right. Next, we are learning about an equilibrium solution. What does it mean? Now, you won't kill the wolf if you answer this. What does it mean normally if you say something has equilibrium?
It's balanced.
It's equal, it's balanced, you got kind of like the same thing.
Same rate for both sides.
Yeah. So an equilibrium solution is where there is no change in the function. It is where the derivative equals 0, which is where you happen to have a horizontal asymptote. And some of this stuff will not make as much sense until the video notes tonight. Tonight we're going to learn about slope fields, which are the graphs of differential equations. And so we're going to start to, some more of this is going to start to reveal itself to us, if you will.
I was so terrified on the final exam because I started to try to do a question and I could not figure out how to do it.
And it had a line through it. Whew, yeah, thank goodness, yes.
It looked like something we could solve.
Yeah. Well, so we'll learn this unit and then we can come back to those and do them. All right. We'll study up until it, but the BC practice exam would just be making you take an extra. Like I might do one on a Saturday for extra credit. I don't do a final. I don't want to double test you guys at the end. So we don't have. LOL, no. I'll probably give you guys something optional. I'll think about it as we get closer to it. Yeah. A color by number for your final? That would be a very intense color by number.
My aunt's professor did that. They had like a color. It was her last year, and like she was doing like a big FU before because they screwed up her whole year. And so her final was color by numbers. Like you would come in, and then like
was it elementary style?
It was like you would do canvas, and she gave you like finger paints. It was a perfect thing color by number for her final. That is great.
All right. Example number 6.
I feel like Miss Rice wants to.
Did you guys miss that part where he said at the very end? At the end, when your job is no longer on the line, or it doesn't matter? All right. Example 6. Find. That sounds like a terrible idea.
Yeah, no, that sounds like a great idea.
Find the equilibrium solution for dy dx equals y squared minus y. So depending on the context of when you're trying to find the equilibrium solution, different parts of this could be what will help you figure it out. So here, the part that would be most helpful is to remember that it means that the derivative is 0. So you're going to say 0 equals y squared minus y. And then how do you solve for y?
Y squared is y. Y squared is y. So that's
Ooh. Yeah. Yeah. Because we're going to factor it. Take out a GCF of y. I was trying to figure out if you killed a kitten or not. And Wolf saved you. He saved the kitten. So we got y equals 0, y equals 1. So this particular differential equation has 2 equilibrium solutions, and they are 0 and 1. And those would also be the horizontal asymptotes for that. And if we graph the slope field, you'd be able to see it, but we're getting ahead of ourselves. So that's as far as we're going today. That was, well, technically it's calculus because this is a differential equation, but we used basic algebra to do it because when we looked at that, we went, oh, when I set that equal to 0, that just turned into an algebra problem. That's very simple factoring. Yes, this is the calculus part, and then this is the algebra. Yeah. Yes. So I took a differential equation class as part of my master's degree. And the benefit of a differential equation is you can talk about, it's kind of like related rates. Do you guys remember the related rates where we have all different variables and each of those variables have a rate of change? When you talk about differential equations, you don't have to limit yourself to 2 variables. You can have lots and lots of variables and lots of rates of change. So we took a whole class and we started looking at like how different things affected different things. So my final project was the level of pay that jobs that are typically female make versus the level of pay that jobs that are typically male make. So like the difference in pay for like nurses and teachers and things like that versus like engineers and construction workers and stuff. And you can compare a lot more data because you can talk about like the age they start working, the degrees you have to get, like how, like whether or not there's maternity leave, all that stuff you can like start to add in. Those are all individual different equations. As opposed to normally we talk about like those projectile motion problems where it's like height, vertical height versus horizontal height, and that's the only thing you can compare. You don't talk about air resistance, you don't talk about gravity, you don't talk about like all the rest of it, you know? So differential equations are good because you can add in, you just like add another variable, and then add another variable, and then add another variable, and you can have like, yeah.
For any kind of complex model.
Basically, yes. So when you get deeper into math and you start to model situations, you're going to ditch all those early models that we taught you. Because basically when we start teaching you math in high school, we make something as simple as possible. So when projectile motion problems, when you have something that like flies in the air, it does not make a parabola. It does not. It's a lie. You've been lied to the whole time. But that's all that you guys can handle at that level. Really, if you wanted to accurately portray that, you'd be using differential equations because you'd have a lot more variables that come into play. Yeah, because it's like, because you don't just have like they usually talk about it as like the things that are affecting it is like the time versus vertical distance. Yeah, so height versus time, those are like the only two variables they consider. But then you also have like air resistance, and you also have like right, the shape of the object, the surface area, like all the things that come into play. Like if it's raining that day, what the altitude is, what the yeah. So when I was in that class, that was our example because we were all high school teachers, and so we took that projectile motion. And then my professor went through like all the different variables that technically should be part of that problem, and we were all like,
I can see why we don't do this.
I can see why we don't teach this in sophomore year math. Yeah, it was terrible. Yeah. I was like, thank you, goodbye. I'm gonna throw those notes away and never look again. So, yeah. So again, we're not gonna go that crazy, but we're gonna do like very basic, whatever versions of that. But it's kind of cool when you get deep into it. It's just very like, whoa, brain matter everywhere. Gray, drippy, gross, you know?
Thanks for that.
You're welcome. All right. Let me... All right. You guys ready? Okay. So what we're doing here, they're giving us a function, and then over here we have to figure out which differential equation it goes with. And when you first do this, it gets easier as you go through the problem more and more, and you're gonna start to notice like patterns like, oh, e to the x is the same for y and y prime and y double prime, so you're gonna start to notice that and like pick things up. The first one is the hardest, okay? So here it says number 1 is e to the negative 2x, and when I look over here at my differential equations, we've got like the derivative minus 2 times x times the original equation. We've got the derivative plus 2 times the original equation. We've got x squared times the second derivative minus 2 times the original equation. Do you guys see how they're all a little different? So what I do when I start this assignment is I just like write out what the original function is, what y prime is, and what y double prime is, and then I try to figure out which one it could maybe fit into. Okay, and then as you go through the assignment, you'll start to pick up like, ooh, those typically cancel out. You'll start to notice like similarities and patterns, okay? So when we look at number 1, we've got y equals e to the negative 2x. What is y prime?
Negative 2, negative 2x.
Okay, and then what's y double prime?
4. Negative 2x.
Okay, so y prime minus 2x times the original function, that would not work. The first derivative plus 2 times the original function. Yes, that would work. So this would be negative 2 e to the negative 2x plus 2 times e to the negative 2x. Those do equal 0. Does that make sense? So that one's done. Okay, so e to the x to the third, y prime is
2 to the 3x squared. E to the x cubed.
I'm going to maybe leave those for a second and only do the next one if I have to.
Well, I mean, there's one with 3x squared right there in it.
Which one? Oh, but we needed y double prime for that. No! Please, no. Actually, that's probably it, though. Okay, so let's go ahead and find y double prime. Okay, so we've got first times the derivative. Oh, that wasn't the first. That was the second. First times the derivative of the second.
3x squared e to the x cubed.
Plus the second times the derivative of the first. Okay, so it said y double prime minus 3x squared times y prime, which would be subtracting off that piece, minus 6x times, yeah, that looks right. Okay, so let me just write this out so that we have it. We've got y double prime, which is 9x to the 4th, e to the x cubed plus 6x e to the x cubed, minus 3x squared times 3x squared e to the x cubed minus 6x times e to the x cubed. Yep. So number 2 is F. Good call.
Thank you.
Okay, so do you guys see how those work? Yeah, some of them are painful. The nice thing is that, like, that one could have been a crazy one, but it was almost like recognizable. Like you might have gone to that pretty quick because of the 3x squared and the 6x. You can kind of see it in the problem. So, have a good time. Enjoy it. Okay? Whew. And the answers are already on the back. Yes, and I will get those out for you.